All right, so we're going to finish up that lesson, and we did trapezoids on part A. Now we're doing kites. So let's draw a kite. I'm going to go like this. I'm going to go like this. Let me make it about like that. Yep. I'm actually going to get rid of some of these lines in a second, but these lines help me draw the kite. All right, let's do this. Let's get rid of this line right here. I'll tell you what, I'm going to copy this so I don't have to draw it every single time. All right, let's get rid of this. We'll keep that right there. You know what? I'm going to get rid of this one too. All right, so here's a kite. And what's our theorem say? Our theorem says, by the way, let's talk, before we write down the theorem, let's talk about what a kite is. Remember what a kite has that we've learned already? It's got these two consecutive sides that are equal to each other. Do you see that? So those two are equal to each other. And then the other two that are next to each other are equal to each other. All right? I think that's the only thing we've learned so far, isn't it? Did we do anything else with a kite? I think we just learned what it is. Did we learn anything about the angles or the... Can't remember. I think that might be all we learned. All right? Was there anything else that we learned? Can't remember. All right, let's write down the theorem. Here's a new thing. So it says exactly, write this down, exactly one pair of opposite angles, oops, not off, of opposite, I'll just shorten that, angles, in a kite are congruent or equal. However you want to say it, I don't care. It says exactly one pair. So let's take a look at it. Which pair do you think it is? So there's one pair that are equal to each other. So there's two angles that are equal. The other two angles are not equal. So which two angles do you think, just by looking, okay? That's not a good way in geometry to really tell, but I just want you to look at it and think which ones are equal to each other. Evan? Yeah, B and D, exactly right. So B and D are the one pair of opposite angles that are equal. Do you remember on a parallelogram you had two pairs of opposite angles that are equal? On this one you only have one pair of opposite angles that are equal, okay? That means, tell me something about A and C. Tell me something about angle A and angle C. They're not equal. Very good. Okay? So A and C are not equal to each other. Everybody got that? So how do you know which ones are equal? It's the ones between the two sides that are not equal. Do you see that? This has got one tick mark. This has got two tick marks. This angle is in between the sides that are not equal. So the angle between the sides that are equal, do you see that? A and C. Those angles don't equal each other. All right? So it's just this one and this one. So it's the one between the two sides that are unequal. Those are the angles that are equal to each other. Pretty simple, isn't it? Now, there is a proof for it. I'm not going to go through the proof. But, yeah, that's it. That's our first theorem. Let's do another one. Everybody write that down? All right. So I just put the little arcs there. Let's do this. While we're here, let's say, oops, angle B. What am I going to write? Equals what? Angle D. All right? Okay. Let's move on. Let's put another kite there. Okay, just happen to have a kite. And I'll just write down the theorem, and we're going to look at it and decide. Actually, you know what they do on this one? If I wanted to make it look like, let's do this. Let's group this. If I wanted to make it look like the one in the book, kind of looks a little bit more like this. Still a kite though, isn't it? Just because we switched the angle of it, or we just turned it a little bit, no big deal. So here's another theorem. So there's three theorems that we're going to do on this kite. We did one already about the opposite angles being equal. These things right here, do you see from here to here, from one point to another? What do you think I call that? We've done this. We've done it on parallelograms. We've done it on trapezoids. We've done it on rhombuses, all that kind of stuff. We're doing it here. What is that thing called? This one that's going up and down like that. It's called a diagonal. Very good. And what about this one down here or across here? That's a diagonal as well. So the theorem talks about diagonals. So it says the diagonals of a kite are perpendicular. Oops. Are perpendicular. What does that mean for two lines to be perpendicular? They're not the same. It doesn't mean they're the same. No, not the same. They're not the same. What does it mean for two lines to be perpendicular? We've used this word a lot, guys. Come on. Perpendicular. It's not parallel. What do two parallel lines look like? What do two parallel lines? They look like this and they never what? They never touch, correct? Okay, what about perpendicular? Donnell, say it. I just heard you say it. Say it again. Donnell. That's it. Perpendicular means they meet at a right angle. Everybody see this? See my markers up here? So perpendicular means that they meet at a right angle. Perpendicular is a right angle. You got to remember that. That's an important word in geometry. If you leave here and a teacher says something to you about being perpendicular and you don't know what that means, I have failed you, or you have failed you, all right? You got to know what perpendicular means. Perpendicular means that they form a right angle. So look at these. I'll put it in red so it pops out a little bit. So these diagonals right here, these two, this one going straight up and down and this one going across, it means they're perpendicular, which means that it's a right angle. So that right there is a 90-degree angle. Very, very important. Okay? All that just in that theorem right there. All right, I'll give you another one. What should I do? I don't know if I want to say all the stuff that they say in this one. By the way, let's do this. Let's name these. Instead of just calling them diagonals, in a kite, they actually have specific names. Remember, those two are equal. These two are equal. Okay. So if I go from one unequal angle to the other unequal angle, right? Remember these two angles right here are not equal to each other, right? We call this thing, where should I'll draw it right here. Okay, put an arrow. See this one that's going straight up and down? We call this the axis of symmetry. Axis, sounds fancy, of symmetry. All right? So the one going up and down, it's not always just up and down. It's the one that connects the two equal sides to the other point where it connects the two equal sides. You see that? Two equal sides right here, two equal sides right here. We call that the axis of symmetry. Now, the one that connects the two equal angles, remember this angle is equal and this angle is equal? That has a name as well. And let's put this over here. They call this the crossbar. To tell you the truth, I really don't care that much if you know that that's the axis of symmetry and that's the crossbar, okay? Knowing that they're the diagonals is good enough. I don't think I'm going to worry too much that you know that it's the axis of symmetry and crossbar. But in my, Algebra 2 class yesterday, we did something completely, it didn't have anything to do with kites, had to do with graphing and stuff like that. We talked about the axis of symmetry. And I told them, I said, hey, remember when you took me in geometry last year, we talked about the axis of symmetry of a kite? A couple of them were like, yeah, I think I remember. Most of them were like, no, I don't remember. But we do refer to it, all right? So there are other times where you're going to talk about stuff being the axis of symmetry. In Algebra 2, the axis of symmetry comes up a lot. We talk about it a lot. It's very important, okay? Right here, not that important, okay? So I don't really care if you know the names of it, but just know that they're the diagonals. Now, I guess in this case with this theorem, it kind of does matter, to tell you the truth, on this particular theorem, because they're going to say one thing is bisecting another. So really, the theorem says this. So with all that said about not being important, for this theorem, I think it is. It says the axis of symmetry, which is this up and down one, in this case right here. So the axis, come on, pen, help me out here. The axis of symmetry, And again, you might be able to look at it and just guess. What do you think this one going up and down does to this crossbar right here, this one going across? Look at where it hits. Say it. It bisects, exactly right. Because it looks like it hits that crossbar right in the middle. Does it look like the axis of symmetry is being bisected? No, because that one's way shorter than this one. So the axis of symmetry is not being bisected. What's being bisected? The crossbar. So the axis of symmetry bisects the crossbar. And that's important. Why is it important? Because if you know it bisects it, you know that, let's do a different color. If it bisects it, you know that this little segment and this little segment are equal to each other. And you know what they're eventually going to do, right? They're going to give you that. They're going to give you a number for that. They're going to ask for this. They could make this like 3x minus 2, and this is 2x plus 1, and you got to find out what x is. Then you plug it back in, and you solve for the length of that little part right there, all right? Or you find the whole entire crossbar. That's something that we've done over and over and over again. We did it yesterday, okay, when we could do it with this stuff as well. All right, I think, let's see. Oh, it does one more thing. It also does this. And, we'll put an and. Why did I put it in blue? Let's keep it in white. All right, and it bisects the non-congruent angles. What does that mean, the non-congruent angles? The angles that are not equal to each other, right? So the non-congruent angles. All right, so what does that mean? Let's go back to the blue. Remember, this angle up top here is not equal to this angle on the bottom here. But this axis of symmetry does bisect that angle. So these two angles would be equal to each other right here. What about these two little skinny angles down the bottom? They would also be equal. Why? Because the axis of symmetry bisects the non-congruent angles. Does this crossbar bisect these congruent angles? Nope. So these two angles are not equal. See this little skinny one and this little skinny one? They are not equal, but these two are equal and these two are equal. But this big angle is not equal to this big angle. There's a lot of stuff to keep track of on this. Right? But if you draw the picture, you mark all that stuff, right? Remember, this big angle and this big angle are equal. This little one right here and this little one are equal. But the big angle up top is not equal to the big angle down the bottom. This crossbar is being bisected, so that's equal to that. That's a right angle. Man, there's a lot of stuff that we didn't know before about a kite that now we know. So let's put all that into practice, and let's see what we get. Let's do this. Let me copy that because I'm going to use that same picture. Then we're going to put some numbers in here, and we are going to hopefully solve for some stuff. All right, let's make this just a tad bigger. Make it easier to write inside. All right, I'll push this over here, and let me mark some stuff. They call this K, I, T, and E. Look at that. I guess they're trying to be kind of cute. So what is this? K-I-T-E? What is it? It's a kite. All right. So that's what they did there. I guess they think they're funny. All right. So since it's a kite, we know that that side and that side's equal. We know that this side and this side is equal. All right. Since it's a kite. We know that the axis of symmetry and the crossbar, what do? Those diagonals, they make a right angle, don't we? And let's put some stuff in here. So they tell you, here's what they tell you, that angle XKE, I got to put an X in there, XKE is equal to 55 degrees. 55 degrees. Where's the X? The X is right here. Okay? So let's mark that. Let's mark it with a different color. XKE, where is that? There's X, there's K, there's E. So what angle is XKE? You go from here to here to here. So this angle right here, they tell you, that that's 55 degrees. Everybody with me? All right. And they ask you to find a bunch of stuff. That's the only, well, they tell you one more thing. Yeah, that's good enough. They tell you something else, but I don't think you really need to know that. They ask you a bunch of things. They ask you to find angle KTE, angle TXE, angle KEX, all right, angle KET, and one more, angle KIE, angle K, oops, come on, IE. All right, they ask you to find all 5 of these things right here. So where do we start? Remember, we know these are 90 degrees up here, so that helps. We got triangles, we got right triangles, we got equal sides. We know that this crossbar is being bisected. We know a bunch of stuff. So let's go from here. KTE, where in the world is KTE? That's what we got to figure out first. There's K, there's T, there's E. So I'm trying to find this angle right here. That's angle KTE. So let's think about it. If this is 55, tell me something about this angle right here. That's also 55. That's right. Because remember, the whole big angle is equal to the whole big angle. Yes? So if I tell you part of this angle, then this one's going to be the same amount. So this is going to be 55. So you can just look at that and tell that those are going to be equal. You also know that this one and this one are going to be equal too, don't you? All right. So let's keep that in mind. All right, so that's 55. So we got one of them. What is going on with my pen today? TXE. Let's find TXE. There's T, there's X, there's E. Let's do this in a different color. Oh, that's easy. TXE. Everybody should just be able to look at it and tell me. It's exactly right. It's 90 degrees, right? So this angle right here, it's also 90 degrees because that's 90 degrees, okay? If they're next to each other, they make 180, so that has to be 90 degrees without any math at all. I like those, don't you? Yep. And then let's do another color. KEX. There's K, there's E, there's X. So which one are we finding? We're finding this little tiny one right here. Remember what we have. Since I got right angles, what kind of triangles are these? They're right triangles, aren't they? So I got a 90, I got a 55. How do I find this little skinny one? Subtract from what? Yeah, I just go 90. You could go 180 minus 90 minus 55. But what's 180 minus 90 every single time? It's always 90, right? So if you have a right triangle and you know one of the angles, all you got to do is take it away from 90. That's the easiest way to do it. So it's 90 minus 55. And what's that? That's 35. Because you got to borrow, right? So it's a 35. So this is 35 degrees. Let's put that in there. So that's 35 degrees. All right? I'll keep green because look at this. KET. They're asking for KET. Remember what this axis of symmetry does. It bisects this angle down the bottom, doesn't it? So what is this angle, this little skinny angle right here, and this little skinny angle right here? Well, they add together, but they're both 35, right? They're both 35, okay? So this would be 35, but what are they asking for? They're asking for the whole thing. Now, Abdul, that's what you're going to do. You're going to go KET, so you're finding that whole big angle. So you got a 35 and a 35, 35 plus 30, plus 35 equals what? 70. So that whole thing is 70. So that's 70 degrees. All right, let's do one more, and we'll be done. Haven't used red much on here, so let's use that. KIE. Let's find that. KIE. That's this little skinny one right there. Good question. You know what? You really can't find it, okay? I will not ask that. There's something else that we can do to it. I'm not even going to talk about that. It's a little bit more confusing. So don't worry about KIE, all right? There's actually, there's actually not just one answer for that. There's a multiple of answers. It's between this and this. I'm not even going to attempt to try to go that route with you. So that won't be, this definitely will not be on a quiz or test, this KIE one, all right? But I could ask you any of this kind of stuff, couldn't I? All right, I could put a kite there, give you a couple things, and you got to find some missing angles. I won't give you one problem with like 5 sections to it, all right? It'll be at the most 2 per problem, but most of the time on a test, it's just 1 per problem. All right, there you go. So you need to finish up that up through number 12 on the first homework, and then here's your new one. We're going to call it section. This is your last homework of this chapter, okay? So get it done because you're not going to have much time to turn it in late or anything, all right? So get this thing done. So this is 6.5b, and you are doing 18 to 25. These are a little tougher. Oops, come on. These are a little bit tougher, so you're going to have to set some time that you're going to really work on it, okay? Really put some effort into it. Don't just write down a bunch of slop just to get, credit for getting it done, all right? Really put some effort into this because you could see some of these problems on a quiz or a test as well, all right? So 18 to 25, that's B. Finish up through 12, all right? And then on Monday, I'm going to collect basically 1 through 25, all right? But it's going to be 2 assignments. You're going to have a part A, you're going to have a part B. So make sure you separate them like that. Don't put them all on just one sheet of paper, all right? I want them separate. Everybody got it? Okay.